Hi, good evening. Thank you very much for being here today. My name is Alan from Cloudera. Um, this is essentially our inaugural, very first Cloudera meetup that we have actually organized here in Malaysia. As you look at what meetup stands for, is essentially a platform where people with common interests come together and essentially try to talk and try to ideate and learn from one another. That's essentially what we're trying to create, a platform where we can share. At the same time, we also want to learn from the rest of our base of community of interest. And very much from there, we would like to create a community where all of us can actually benefit from the kind of technology that we are being put in the market. So essentially, Cloudera is pretty much the platform for design for this machine learning and analytics, optimized for the cloud. In Malaysia, for the past 2 years, essentially I've been here I've been with Cloudera for a year. It was a very exciting year. I started to see quite a bit of organizations out there going through massive transformation, leveraging on our technology. Majority of them has started to start their journey very much looking at data, um, uh, to very much to be able to have insights of the data. But those are just the starting point. But essentially from the platform that we have put out there today, we're starting to see the evolution of how customers are starting to adopt a lot of this, a lot of our platform, taking from looking at insights to doing very advanced analytics towards machine learning and now moving towards AI. Today, we are very privileged, and I would like to give a big thank you to Axiata, Pedro particularly, and Axiata Group for sponsoring this particular event, letting us to use the facilities here today. Um, uh, in the meetups, we typically like to have both sides doing a cross sharing. In this instance, we are very pleased today to have Doug Cutting, our chief architect, and also um, the father of Hadoop, which essentially created this platform uh, that has fundamentally has actually started and built a foundation towards big data and also towards where a lot of companies are leveraging on this platform to do analytics and machine learning. Um, without spending too much time, without wasting too much time, and I'd like to very quickly introduce Doug Cutting, our chief architect, uh, to talk a bit about the big data journey, um, how it all started and how it has evolved over the years, and what's the next big thing ahead of us. Subsequently, today we will also have Pedro. Pedro is very exciting to see that there's also Pedro, which is the founder and also the very much the head of Axiata Analytics Center, um, where Pedro is actually working with various different opcos within the Axiata group, uh, ranging from operating companies in Malaysia all the way to Nepal, Bangladesh, Cambodia. They are actually using analytics and using data significantly to drive various different competitive advantages out there today. So we'll see two different speakers today. The way we like to run the format today is very much to have Doug uh, have shared with us on the data journey, and subsequently I'll introduce Pedro later today, and towards the tail end we'll reserve some time for Q&A. Okay. Without further ado, can I please welcome Doug Cutting.
Thank you very much. It's an honor to be here with you all. So yeah, as Alan mentioned, I want to talk about the big data journey in general that I've been on, the way I happened into this this career, the way that the industry seems to be developing, as well as the pattern that I've seen different organizations go through in adopting these technologies. It's important to first mention sort of the greater context of digital transformation, which I think is the phenomenon that we're all a part of, and that big data is the latest stage in, where we're really seeing industries and governments and societies using data as their dominant fuel in this century. And so I think we're actually at the very early stages of this transformation. We're still only scratching the surface of what we can accomplish and will accomplish. So it's, I think, a very exciting time to be working in this area. I think there's a lot of new ground to be broken, and I encourage you all to be bold and think about how you can really affect big changes in your organizations, because I think there's a lot of potential for that still out there. So going back sometime into the history of these tools, I spent some years working on non-open source software and proprietary software through the 90s, mostly on search engines at a variety of companies. I worked at Xerox PARC, I worked at Apple, I worked at Excite, and enjoyed that work very much. I was fortunate to start working on search engines before there was web search, by chance, more or less. So I was well prepared for the web when it happened. I had a nice role to be able to play there in building some of the first generation of web search engines in the late 90s. But I was worried then that the hype around the web was a little overheated, and that the company I was working for, in particular Excite, might not survive, and I wanted to have a backup plan. So I wrote some search software on my own time in a then new programming language called Java. I called this search technology Lucene. And I wrote it in perhaps, I think it was the winter of 1997, 1998, and didn't do anything with it for a few years. And then 2000, Excite actually went bankrupt, and I didn't have a job. And I was, thinking about what I should do with this. Should I try to sell this software? Should I try to build a business around it? And I had no desire to become an entrepreneur and try to come up with a pricing plan and legal contracts and hire people, and all those things were the last thing I wanted to do. I wanted to work on software with people, and moreover, I wanted software I'd worked on to get used. I'd really enjoyed that, working on web search. It's very rewarding to see what you've done be useful to people and help them in their lives. And now I had some software which hadn't really enjoyed that. So I thought, why not give it away as open source and just see what happens? And maybe I'll be able to make something off it, and maybe I won't. But at least it'll have a shot of getting used. A few people started using it right away, and they started hiring me as a consultant to help them use it pretty quickly. And so I was making the same income that I'd been making before. Giving software away didn't actually cause me to stop making any money from that software. Then people were using it a lot, and they were starting to make changes themselves and turn them back in. And this process really took off. And in the 18 years since then, probably every part of Lucene has been rewritten multiple times. It's gotten phenomenally more evolved and improved. And it's probably one of the most used search technologies out there. It's behind many of the search sites you see. So it's inside of Solr and Elasticsearch. It's inside of Netflix. It's inside of all kinds of products that have embedded search. It's not, of course, used by Google or Bing or some of the big web search engines, but more often than not, in an embedded search site, they're using Lucene inside. And I would like to, my ego would like to think that it was because it was, brilliant technology, but I don't think that's actually the case. I think had I tried to sell it, I would have gone out of business. And that rather, it was this open source model that propelled this technology much further than it could have gone any other way. That people enjoyed this frictionless ability to try it without engaging in any long-term agreement with anyone, without building a dependency on another firm. They could try it. They could see into the software because it was open source when they got confused about how to use it. Many times figure things out themselves. They could make improvements themselves. For whatever reason, it was a phenomenally successful model to get software adopted and to get it developed and improved. Developers, when they're contributing to open source, care more about the quality of their contributions because they know the whole world is going to see them. It will be associated with them in public for posterity. You can't, if you're working at a company and working on code that's never going to be published, you can do really ugly things and not add any comments, and very few people will ever know. Whereas if you're working on an open source project, everybody knows what you've done and they associate it with you. So that actually raises the quality, I think, of a lot of the contribution. Anyway, I was very pleased by this, by how well Lucene had done, and I wanted to do more open source. So I started to work on a probably overly ambitious project, certainly overly ambitious project, trying to build a web search engine, a crawler, indexer, the runtime search. Everything is open source, so sort of an open source version of what Google does. After a couple of years working part-time, I was able to get some folks to pay me a little bit to work on it, and I had some friends who I was able to recruit to help work on it. We had something that we could run. Now the web, even then in 2003, was too big to fit on one computer, so we knew we had to have a distributed solution, and we came up with some simple ways of dividing the computation and spreading it across a set of machines, and then running a series of processes. And it was more or less a full-time job to run it on 5 machines in parallel to monitor things and move each thing to the next step when it had hopefully succeeded, and managing the disk space on all of these machines and so on. So I was in the middle of that and realizing that this was not going to get us to, the way the web was growing. This solution would probably become impossible to operate at some point. When Google published a couple of papers about the way they had done things. They had a system called MapReduce to divide up computation, and a system called the Google File System, GFS, to distribute storage. And the thing that they had done fundamentally was automate the reliability of this, so that if there was a failure anywhere, things would keep running. So you could run a computation and not worry about monitoring each individual machine. You could treat them all as a single large virtual machine, if you will. And similarly with the storage, if you had a failure, things would automatically be already replicated. They would re-replicate, and it would heal itself. Moreover, the idea of distributed systems was not new, but a way to do it that was relatively simple and tractable to implement was novel. Any of you in this room could read those papers from Google and say, "Oh yeah, I could build that. It's not too complicated." And here I was a person who had a need for that when those papers came out, and so it seemed a fairly obvious thing to implement them as a part of this search engine project we were doing, Nudge. So we started on it, and I also registered that at the time I had friends who worked at Google, and they would tell me, yeah, if I want to run some experiment over 1 billion web pages, I can write a 4-line program and submit it, and some minutes later, I'll have the results of that program, and it will have run on thousands of computers in parallel over a petabyte of data, and this was unavailable to anyone else besides these folks at Google. There was literally no other way you could write software which did that. It just didn't exist in the world at that point. And I realized that if we did this as an open source project, for one thing, it was a useful enough concept that you could probably build a community around. You could probably get a lot of contributions, the way I'd seen with Lucene. But moreover, you could enable people to approach problems that they couldn't before. I'd worked earlier in my career on speech recognition, on various other natural language processing problems, and knew how amenable these were to data. But most people didn't have the facility to process large amounts of data, especially at low cost on inexpensive hardware. And that if we had an open source solution, it would enable a lot of people. And I was thinking more about people in building web search engines, people at universities doing research projects. That was my world that I lived in, and that was what I imagined this would be useful for. So a couple of us set about trying to rebuild this. A couple of years later, by 2005, we had Nutch up and working on top of this style of computation. We could now run it on 20 machines, because that was as many as we could find around to try it on and to develop it on. And it wasn't rock solid by any means in 2005. And we realized that distributed systems are much more complicated to develop. The ways in which they can fail are far more numerous when you're depending on other systems. There can be all sorts of timing problems, deadlock problems, you name it. It's very, very long tail of bugs in a distributed system, and realized that it was going to take more than a couple of us working part-time to deliver this vision of inexpensive, large-scale processing for everyone as open source. So I realized we needed help. We needed someone who had more engineering talent, more hardware to develop it on. I looked around. I talked to a few different companies. I found Yahoo was interested in trying to compete with Google in those days, build their own web search engine. So I joined Yahoo in January of 2006. We took these distributed computing parts out of Nutch and started a new project. We needed a name. My son had this, some years earlier, it had this little stuffed elephant toy, and he had, running around as a toddler, made up a name for it, which was Hadoop. And as a software guy, I knew that names are hard to come up with good names, and then it's also hard to come up with a cute mascot or an icon for a project. But good projects had unusual names and had mascots, and here was one handed to me on a plate by my son. This yellow elephant named Hadoop, and so I'd been saving that name for a good project, and so we christened it Hadoop in January of 2006. And on day one at Yahoo, had hundreds of machines to start developing on, maybe a dozen developers now trying to work down that long tail of bugs, to add the needed features to make it actually useful. And by 2007, we had really reached the milestone where we had a usable system that was enabling people to affordably and easily process petabytes of data on up to thousands of machines. And so I was sort of ready to think about something else to work on. And when people started to approach me and say, this could be much bigger yet. I'm sure it's useful to folks at websites trying to analyze their user behavior and build the search engines, and maybe do some natural language processing on very large text collections. But it's probably also useful in many other places. These are people who were thinking about this digital transformation and realizing that pretty soon every industry was going to be swimming in data, and that the existing set of tools that enterprises were provided weren't up to the task, and the methodology that folks were using wasn't up to the task, and they believe that Hadoop formed the kernel of a next generation of data systems for enterprises. I didn't believe this. I didn't think that enterprises would ever use crazy open source stuff written in Java. I thought that it was an impractical belief, and I said, go ahead, start your company, and tell me how it goes. So they started Cloudera in 2008, and after a year of thinking about it, I realized, well, I wasn't sure they were right, but I thought there was a chance, and if they were right, it would be pretty fun to be a part of. To try to, it was a bigger challenge to try to meet the needs of all these other organizations. There's a lot more concerns when you're working in regulated industries. Security starts to matter. You've got a lot of other problems that you have to solve. So I joined Cloudera in 2009, and we really saw the vision that the Cloudera founders had bloom and really came true. I think to a large degree, it's still coming true. One thing that I thought was another thing I hadn't predicted at all was the style of development that brought about Hadoop became sort of the norm in data systems, where some crazy guys build some system that because they have a need that nobody's meeting, they publish it as open source. Other people find it and on GitHub or something, and they try it and they find it meets their needs too. And before long, it becomes the standard way of attacking a problem. We've seen that with Spark. We've seen that with Kafka. We're seeing that again and again. And the result of this is we're getting this very rapid evolution in systems, in capabilities. And moreover, these capabilities are appropriate for the challenges that people are facing. By definition, because they're developed in response to the demand of institutions. That's how you get the groundswell that creates an open source community, is that a lot of people are finding it useful. And so it's giving us this very rapid evolution that's of appropriate technologies to the challenges. Really a pretty strong system, I believe, of producing software that I think is actually going to be the longer legacy of Hadoop, rather than any particular technology, is this process of inventing and evolving technology. So now we're at a place where we have available to us a much improved set of tools. We've got a variety of different SQL engines that run in this ecosystem that are good for different kinds of tasks. We've got search systems like Solr and Elasticsearch. We've got machine learning tools. We've got stream processing tools, and it keeps expanding. And so it's a wonderful set of capabilities for folks who are trying to attack these problems. And it comes with a different way of working, fundamentally. We're now able to store much more raw data, to experiment and develop solutions iteratively and incrementally, and that we used to end up with these isolated, siloed systems. The process of building a system was very much this, you spend a lot of time gathering requirements, designing it, the waterfall approach, implementing it, deploying it as sequential steps, and you hoped you got it right, and you usually didn't get it quite right, but you didn't have a lot of ability to change it because you'd transform all your data by the time it was stored, and you couldn't go back. And now we enable a very different style where you can collect large amounts of diverse data, try out a solution. If it doesn't work, try another. Get something that shows good signs, and then incrementally improve it, constantly testing it. And it's a better methodology, and you can use it. You have this wider palette of tools to do it with. And we're seeing people make amazing progress in their data systems. The challenges are though are there. It's not nirvana. One of the biggest challenges is that this style of development is foreign to organizations, and the way you want to manage this kind of a system requires a different kind of management, requires a different organizational structure in most cases. You want to have one group of people who's managing the base platform system, but you would like to have people in the businesses actually developing more of the software, more of the queries, more of the algorithms on top, which long term I think is the right use of organizations. We want to get the technology out where the expertise is in business units and not try to centralize. But it's very hard for organizations to change it. And I think that's the biggest impediment I'm seeing right now to adoption of these technologies is cultural, is the style of organization that can successfully adopt it is different. So I think one of the so it's not usually a technical difficulty in adopting these. And so the method that we've seen people succeed at is actually similar to what we saw at Yahoo back in the origins of this. Yahoo was trying to build a web search engine, and which was a big endeavor. It was going to take them many years, but in the process, we had an early version of Hadoop up and running. We put in some data sets. We put in some logs of user interactions on the website. We put in some web pages. We had a large number of collections, maybe some advertising sales data, and then people came up with ideas of experiments. And long before Yahoo moved its web search onto Hadoop, they had 6, 8, or 10 different products which had been created out of this experimental process using this system. Things to do a better page layout, because they could finally understand at a large scale how people were interacting with the pages. They would log everything on the page, and then they could see and where it was on the page, and then when they got a click, they could see where that was on the page, and they could figure out what parts people had looked at and skipped over, and where they had stopped, and really understand people's interactions and their sessions on the site in a way they never had before, and use that to optimize the website. They could build spell checkers. They could build things to propose corrections to people's queries, alternate terms they might add. All these sorts of improvements in the advertising matching to improve ad click rates and improve revenue. All these things appeared before the primary target of moving web search on. So I think that the lesson here is to facilitate experiments. Also Yahoo started with a relatively big project. I think more people are successful when they start with a relatively small project, one that's fairly simple and has a high likelihood of success. One of the most boring, we were talking about this earlier, one of the boring things that people do first, and which I think is actually a smart thing to do, is to do data warehouse offload. You can save a lot of money by doing a lot of your data warehousing on a Hadoop-based platform, and in the process, you're going to build up some competency. You're going to get a cluster going, and you can then start this experimental process of doing more interesting, higher value things. But you've already paid for the cluster. You've already had a success story that you've been able to use to gain this experience. So I think you're well advised to start small and simple, and to grow this new culture within your organization. At the same time, it's critical that you have understanding from the very top of the organization from the C-suite that you need to become a data-driven organization, and it will require some fundamental changes. You can't make them overnight, but you do need to have an eye on that. Also with the understanding, I think we used to sort of try to, coming up with a perfect schema for data, and believe that we could build a system that would last forever. And I think it's a much more realistic approach to realize that we're going to be constantly changing things. We're going to be constantly discovering that the things that we built a couple of years ago weren't done the right way, that we've realized better ways of doing things. And so engineering not just our systems, but also our organizations to be able to be flexible and constantly changing, I think is the thing we need to be doing. So use this opportunity to not try to craft, as you change the organization to adopt these technologies, not make that same mistake again of crafting an organization to just satisfy the new solution you're building, but rather build an organization that can adopt new techniques, can experiment and develop new methods, and keep your business moving over the long term. So I realize this is not technical advice; it's organizational advice. But it's again and again when I talk to folks, the fundamental problems they're having aren't technical. There is a lot of wonderful stuff going on in technology, amazing leaps being made in machine learning, for example. But I also discourage people from getting too excited and trying to jump right in with a machine learning challenge. There's a hierarchy we talk about of analytic data systems where you start out with sort of simple analytics, which are counting. Then if you sort of do some fancier counting, some clever counting, then you might call that data science, where you're actually doing some statistical analyses and a little more elaborate mathematics as you're counting. And then you get to counting with some feedback from the real world, and that's machine learning. And you don't need to start there. There's so much that can be done by simply gathering data together that wasn't together before, and being able to get that overview and counting things that you couldn't count before. So I think that's a useful thing to remember as well. I'll wrap up here pretty quickly. Seeing a lot of excitement around cloud as well, and move to the cloud. I think it's in many ways makes this transition to these technologies easier, because it can be pay as you go. It enables people to do these experiments out in organizations more easily, without necessarily changing the core central systems. On the other hand, though, it's not always the most economical approach. It's not the most appropriate for every challenge. I think we're going to continue long term to see a mix of on-premises and cloud for the future. I think that's what is sensible. There's also a lot of cases, I suspect you guys are in industries that are regulated and not permitted to operate things in the cloud yet. And so that's another reason to stay away, of course. So I'm going to just leave you with this notion that, again, I want to repeat, the possibilities out there, I think, are enormous. And you all have the capacity to be innovators, to really drive this forward. It's still very much a young technology world, and I think it's I encourage folks to take risks, to do things that they believe are a better way of doing things, even if it's not exactly what someone asked them to do. To be to not be afraid of failing. I think that's the way you're going to achieve the greatest amount of success. So I think there's a lot of real possibilities there for folks. So hope you're not afraid. I'll stop there. I think I've gone long enough. I think we're going to have some questions later. Is that the plan? So thank you for your time. You want to introduce Pedro? Thank you.
Thank you, Doug. So, Doug actually presented the same pitch earlier this morning. We were actually very pleased to be invited by MDEC and also Sunway University to pretty much greet and share and speak to an audience of about 300 over students today. In Cloudera, we actually have a program called the Cloudera Academic Partnership Program, in which we actually provide our syllabus to these universities where it's being incorporated into their syllabus and to be taught. In fact, in Malaysia, we have about approximately 10 universities today. And Sunway University was essentially one of the very first pioneers. They actually produced their first batch of graduates with the kind of skill sets today. We believe this is the approach that we are addressing in the nation in producing the kind of data experts or the data professionals out there. We are expecting the next batch of students of approximately 10 times more, actually more than 10 times, about 100 over students in 2019. So thanks, Doug, for that. In some of these meetups, I just want to reiterate, yes, there's a lot of best practice sharing in which Pedro will be coming up to talk about some of the top 25 mistakes that you should avoid, right?
Yeah, worst practice sharing.
Yes. So, but I think we also want to stress in the subsequent meetups, which we are also very envisioned to do, is we also would want to establish a technical forum whereby we would like to be able to share and also to be able to update some of you guys which are technical in this room on where we are progressing. So, without further ado, Pedro. Thank you.
Thank you. So thank you very much. I mean, it's really great to have that cutting here, and it's really great to have the opportunity with Cloudera of hosting this event, right? So I'm going to introduce myself. My name is Pedro. I am heading analytics here in Axiata. I've been doing this for almost 2 years. I originally come from Spain, but I have been living in Malaysia for around 4 years, right? So before working in Axiata, I was working in McKinsey in the Kuala Lumpur office as well. So as Alan said, I'm going to talk about the worst practices, right? You can see that I am around half the size of that cutting, not only physically, but intellectually as well. Intellectually on a logarithmic scale, which is even worse. So I hope not to disappoint you after having listened to that cutting, right? Very good. So this is an external presentation, right? So there are people here from a lot of companies. So who is here from Axiata? Raise your hand. From Celcom? Okay. We have people from Telecom Malaysia as well. So who is here from Telecom Malaysia? Only one? No, but there were many people registered for Telecom Malaysia. Okay, very good. Who is here from Digi? These people from Digi. Okay, good. And who is here from Maxis? Very good. And Maybank? Very, very good. We also have Malaysia Airlines, right? Malaysia Airlines? Good. And we have RHB and RHB? Yeah, there, right? And many other companies. Very good. So the first thing I want to say is that nothing I'm going to talk about today is related to Axiata, because this is an external talk. So I'm not going to talk about Axiata. I'm going to talk about things that I have seen, maybe when I was in McKinsey, things that people have told me when I have interacted with them in conferences. Sometimes I have met my peers in other companies, and they told me stories, right? So this is what I'm going to talk about. According to McKinsey, if you listen to McKinsey, the opportunity of analytics and artificial intelligence is between $9 to $15 trillion per year over the next decade. $9 to $15 trillion, and this is a huge number. But just to put this in comparison with something, 9 to 15, let's say 12. What is $12 trillion in the world? Is there something you can see comparable to $12 trillion? Eh? The US GDP, you say? No, US GDP is $18 trillion. $12 trillion is the GDP of China. So basically, this means that artificial intelligence and analytics are going to create an opportunity per year the size of China over the next decade, and this is huge. However, when you look at people, when you look at your companies, when you look at people in the street, when you look at yourselves, you say, well, it doesn't look like I am creating value the size of China every year, right? So it looks like people are finding difficulties delivering this value. And this is what I'm going to talk about. I'm going to talk about the different ways you can fail. In general, according to McKinsey as well, a chief data analytics officer stays in his job for 2 or 3 years. I am already in my second. So that means that next year, maybe I have found one of the 25 ways of failing. So I'm going to talk about these ways of failing. And there are many different ways. So I'm going to talk about different ways, different errors you can make in strategy for analytics, in people management, in execution, in technology, as well as in finance. So this is what I'm okay. So let's talk to the number one. The biggest mistake that I have seen in analytics in many teams is not working on problems. Let me put it in a different way. Is working on problems that are not worth solving. Is not prioritizing the real problems that the company has. Working on problems that are derived from some technological interest that the data scientists have, but are not of value to the company. And this is the biggest thing that I have seen wrong. So typically the way it happens is that people start asking questions like, what can we do with blockchain? What can we do with deep learning? And the reality is that it doesn't matter, because what can we do with blockchain is the wrong question. The right question is, how can I solve my customer experience problem? The right question is, my competitors are growing at 10% and I'm growing at 5%. How can I solve that problem? Those are the right questions. But what you can do with technology is the wrong question. And if you start with technology, you're going to fail. You have to start with a business problem, not with a technological solution. Typically what happens is that business leaders usually don't understand the language of analytics, and they come to you with a data set, and they tell you, please find actionable insights in this data set. But the problem is that the data scientists in general do not know what is insightful versus trivial. And they cannot communicate in a language that the business leader is going to understand. So finally, they solve whatever they understood in a way that is often too complicated and is often wrong, is often not of use for the company, right? So this is the biggest mistake that I have seen. The worst mistake that a chief data analytics officer can make is not understanding the business priorities of each one of the business units. And that means that this person has to be needs to be a combination of a business and a technical profile, and has to be very much on the daily operations of the companies. Otherwise, you are going to fail, right? So this is number one. Number two, also related to strategy, is having the wrong expectations about analytics, right? A lot of people think that analytics is something that is going to bring you immediate returns, immediate ROI. And the reality is that this is not going to work like this, right? Maybe 20 years ago, you were working on an Excel model in the 2000s or late 90s. You were working on an Excel model, and you were able to implement some insights derived from that Excel model that brought you a huge amount of value. But as data becomes more complex, as opportunities become more complex, you are not going to be able to do it with an Excel file. And I am the happiest person in the world when I can solve a problem with an Excel file only. It's just that analytics requires a lot of time. It's a midterm solution. You need to plug data into the systems, then you need to have a high investment in OpEx, which is people, and in CapEx, which is systems in general. And there is no Shangri-La storytelling. You are going to have midterm returns, and it's not going to be immediately, right? When it comes to revenue increase, probably it's going to take longer. When it comes to cost cutting through analytics, probably it's going to be shorter, but it's not immediate. So this is the second thing that I have seen. Number 3 is relying solely on vendors when it comes to modeling. And this is something that I have seen again and again. And I was working in one of those vendors, that is McKinsey, right? So typically the way it happens is this. You're a business leader in a company and you want to implement some analytical models, so you hire a consultant to do that. But you tell him, okay, I want you to implement this, churn, cross-selling, upselling, whatever. And you tell him, but at the same time, I want you to develop my people. The consultant says, no problem, yeah, I will develop your people. I will do it in a way that I involve your people and they will learn. Typically what happens is that the consultant oversells the project, and then one day you go to him and you tell him, if you don't bring me value in the next month, I will stop your contract. And that day, capability development dies, because the consultant is not going to focus on that anymore. I think outsourcing data engineering to third parties is kind of okay. I could live with that, but I would never outsource modeling to third parties, honestly. The analytical models that you are building are the brain of the company. How are you going to outsource your brain, right? I would be very selective getting help from consultants. So, because capability building through consulting is something that involves a lot of misaligned incentives. It's very difficult, right? So this is number 3. Number 4, not prioritizing. Yeah, this is very typical. So basically you have 5 fingers, right, in your hand, and that basically means that you need to have 5 priorities. If you have many more than 5 priorities, probably there are going to be too many. If you have less than 5, probably you didn't think enough. And this is so simple, but a lot of people don't get it. If you are not able to spell out your priorities by heart, because there are so many, you are never going to succeed. You are never going to be focused, right? And typically, this is what happens. So I have a friend who was heading analytics in a very famous company that unfortunately closed down. And he had to look for a job. And then he started interviewing, and he was asking, what are your priorities? And a lot of companies said, well, upselling, cross-selling, what everybody says. That basically means that they have not thought about it, right? So you can have around 5, maybe you can have 5 and a few fingers from the other hand, but having too many means that you are not going to focus, and it means that you're going to fail. Saying yes to random requests. This is number 6. It happens all the time. You get hired as head of analytics, and you have some vision about driving a transformation program and all that. But initially what is going to happen is that most likely you are going to be attending random requests like glamorous visualizations, reports for very narrowly defined projects that finally end up in analysis paralysis, and nobody's ever going to make a decision. I think it is important for a head of analytics to have the maturity and also the stature to be able to say no to some randomness, so that you can focus on projects that really add value, on those projects that are priorities for the business, right? And you don't work, as I said before, on projects that are not worth solving. And these are the 6 mistakes that I have seen in strategy, right? So we can talk about human resources, right? And this is also very, very interesting. The typical question that I get from people internally, externally, is how should I organize analytics? That it has to be centralized or decentralized? This is the typical question, right? I would say that this is a mistake initially to let too many analytics teams flourish in each one of the departments of your company. So you have an analytics team for procurement, another analytics team for marketing, another one for whatever you want. I would say it's a mistake. I would say analytics needs to keep a balance between centralization and decentralization. But being completely decentralized is a mistake. And let me explain what I mean. Analytics needs to be balanced because learning is done best in a centralized way. You learn better when you are together, and execution is done best in a decentralized way. When you have different people in different departments driving the same thing, it's easier to execute something. And you need to keep this balance. If you think about self-driving cars, all the machine learning of the cars, how they learn, how the algorithm gets improved is centralized. However, the driving decisions are made in a completely centralized way. Each car is decided on its own. And with people, it's the same, right? So there are many models that are more or less centralized or decentralized, so you can have people in different, a mini analytics team in different departments. I think it's wrong. You can have a completely centralized team that is sitting in one of the departments. That could work. You can have a center of excellence, which is somewhere in the middle, or you can have a consulting approach. I would say that the center of excellence or the consulting approach are typically not that bad. What is wrong is to start with multiple analytics teams in each department. And there is one fundamental reason for that. And the fundamental reason is that the value of data increases with the variety of the data that you have. If you are doing marketing analytics, you probably are not going to go that far. But if you are able to merge those, the marketing data with, for example, telecom network data, you will be able to make models and extract insights that are much more interesting than if you are doing it in an isolated way. So that's why I'm saying that total decentralization is probably not the best way. And then the question is, okay, so you are saying that total decentralization is probably not the best way to start, and I think it's not. I think it's probably as you are becoming more mature, you are becoming more decentralized, but to start with is not the right way. So the question is, okay, you are going to be more or less centralized, so where should you sit? Where's your analytics department should sit? And here I see again and again, many times companies structure their analytics team reporting to a function that does not drive business operations on a daily basis. And I think it's wrong. I think the power of analytics comes when it is coupled with daily operations, and those operations can be marketing. I think it's the wrong thing to sit analytics under IT. I think it is the wrong thing to sit analytics under finance. I think it's the wrong thing to put analytics under strategy. I think analytics has to be on operational functions, ideally on that function that is the most important for the particular industry where you are. It could be marketing, it could be logistics, it could be network operations, it could be whatever it is in your industry, but I think it has to be organizationally coupled with daily operations. Otherwise you are going to do theoretical exercises. Okay. Another question comes about the head of analytics, the chief data analytics officer, right? So how should this person be? Typically, I see two kinds of problems. I see sometimes some heads of analytics that are absolutely technical, and I have seen it in Thailand, in some banks, et cetera, like you hire a PhD, super specialized PhD to be head of analytics. And I have seen some cases in which you have a head of analytics that is totally non-technical. Both of them are wrong. And I think these are two ways of failing. For me, the head of analytics has to have a combination of being technical enough to be able to talk to technology people, to be able to talk to data scientists. Maybe he's not going to problem solve in a very value-adding way with them, but he understands what they say. And at the same time, this person is able to talk to the CEO, right? So this is very, very important. Having a head of analytics that is able to go to talk to everybody in the organization, from a technical person to a CEO. This is fundamental. And the reason is this. If you want to increase the scope of analytics, if you want to increase the reach of analytics, you need to have somebody who is able to be elevated at a level that he can talk to the CEO, right? If the person is very technical, it's unlikely to increase the scope of analytics to the whole organization. And oftentimes, that influence of analytics should go beyond your own department. If you want to influence the processes that are under other departments, you will have to influence them indirectly. That's why being a business-oriented head of analytics is important. Number 10, attracting talent only through base compensation. This is very typical, especially in Malaysia. I totally understand base compensation is very good to attract talent. Typically what happens in Malaysia, and probably you know it better than me, right? Typically what happens in Malaysia is that you are a data scientist, you go to another company, you get 30%, no questions asked. You just say that you are a data scientist, and any of the banks in Malaysia, some of them are here, they're going to pay you 30% more. The other thing that they do is quite typical, is that because data scientists are typically young people, right? So young people don't think so much about the future. I wouldn't think so much about the future, right, if I am young. So typically what happens is that, okay, so if you take a 2-year contract rather than a permanent contract, they pay you 50%. Some of the banks do that, right? I think it's fine. So base compensation is going to help for recruitment. However, base compensation is not going to retain anyone. What retains people is growth. And that growth can be economical, can be professional, or can be personal growth, right? So what I see as a best practice is to link compensation with some growth in an organization in a way that is probably higher than the growth than other people, because you want to retain and attract data scientists. So base compensation probably not the best way. Brand investment on the brand is very, very important. And here we have seen companies that are doing datathons and hackathons for recruitment. There is one bank, CIMB, did it last week, and also in Axiata we have done it as well, right? So that is good. Number 11. The 11 mistake is hiring the wrong people, and in particular, a lot of companies hire people who are over-specialized. People who have, I mean, don't take me wrong, I love PhDs, and there are PhDs in my team, but especially if you are not a very big company, or even if you are a very big company and you are starting, hiring people who are too specialized is probably not the right way. The kind of people that I personally love is people who are flexible and people who are willing to learn. When I interview somebody, when I talk to people, I don't think about how much you know. I don't care about how much you know, honestly. The only thing I care about is about what you can learn. And the flexibility is really, really important, right? So hiring people who are over-specialized, who go to a board meeting or a steerco and start talking to the CEO in a jargon that the CEO doesn't understand is probably one of the ways to fail, right? But having said that, there are some positions in which you may have a role that requires that specialization, right? So maybe you are driving a project, like for example, in image processing. Now we are working, for example, in voice. There are positions in which you might need people who are very, very specialized, but you need to keep a large amount of people who are flexible. And finding the balance is very, very important. So this is number 11. Number 12, not bringing domain experts or analytics translators. This is fundamental. Analytics translators is kind of an internal consultant that is able to bridge the gap between the business function and the analytics department. Because I told you before that they don't speak the same language. It's difficult to make them talk, and often they don't speak the same language. So oftentimes, what works best is to have a person who understands both. And this is a person who is non-technical. Harvard Business Review calls them analytics translators. Here, we used to call them analytics consultants. Well, this is basically somebody that is bridging the gap. Is making sure that the project runs end to end, from understanding the requirements, from talking to the stakeholders, from making sure that the solutions we are giving are practical and implementable and really solve business problems. This role is fundamental. And this person has to be a subject matter expert as well. Not having this kind of people in an analytics team basically means that you are going to be a theoretical function that is not going to drive business value. Sometimes I ask people, what is the economic impact of this thing that you are doing? And sometimes they don't know how to answer the question. And I'm surprised. And then if you don't know the economic impact of what you are doing, why are you doing that? Right? So I think it's very, very, very important about HR. Number 13, not creating a data-driven culture in your organization, right? Analytics is, or using data is not something for technical people, it's something for the whole organization, right? Even if you are able to make the best models, if nobody understands them, if nobody has the reflex of using data first every time that you have to solve a question, it's not going to work. In many organizations, the reflex of people every time they have to solve a problem is to ask their boss. In some organizations, is to ask the highest paid person opinion, right? The highest paid person opinion is typically the way to go when you have a problem to solve. It's typically not the best option, right? So creating a data-driven culture is very, very complicated. In every organization, the culture of the organization is nothing else but the culture of the boss. Everybody's going to mirror you. And if you are the CEO of a company, your culture is the culture of the company, period. That's it. So the culture of any company is just the culture of the CEO. That basically means that the CEO is the most important stakeholder that you have in order to change that culture. And evangelizing the power of analytics to the C-suite and the CEO is fundamental, because those are the guys that can change the culture. You cannot change the culture. There is a McKinsey study that I read some time ago that identifies the following thing as the best predictor of whether a company is going to be successful in analytics transformation or not. And that predictor is having somebody in the C-suite with an advanced degree in engineering, in mathematics, or in statistics. So basically, if somebody in the C-suite, ideally the CEO, is very much about data, it's probably going to work, otherwise it's not going to work. In order to transform the culture of the company, you have to do a lot of things like communication, over-invest in communication is super important, newsletters, something like this, for example, as well, is very, very important. If you neglect the organization, everything is going to fail. It's literally going to fail. And number 14, being biased. I think I talked a little bit about this. Analytics has to be independent enough to be able to challenge the status quo of the business units. Oftentimes, what I see is that you, a data scientist or somebody in analytics, thinks that the company is doing something wrong and is able to prove it. Is able to say, we are investing in this part of the country and it's useless. Is able to say, we are doing the wrong campaigns. Is able to say, we are doing the wrong things here and there. And they don't say it because they are biased. Because sometimes, and I think here the maturity of the chief data analytics officer is important. So being independent and being biased and not just complying with the status quo is very, very important. And it's something that I have seen a few times. So we go to execution. Right? In execution, we have 5 ways of failing. Number 1, not embedding analytics in day-to-day operational workflows. This is very important. So I was saying before, analytics is your brain. But it doesn't matter how much you think. If you are not able to embed the decisions of your analytical models in daily operations, you're not going to walk. So even if your brain is saying you have to walk, you have to catch that rabbit. If it is not connected to your legs, it's not going to work. Right? So embedding analytics in operational processes is fundamental. This basically means bridging the gap between people and technology. And these operational processes is probably the process that determines how campaigns are defined. This is the process that determines how a person, a client of a bank, gets an approval or a rejection on a loan. This is the process that defines how you invest in CAPEX. This is the process that defines a lot of these things. This is the process that defines, for example, how you allocate your performance appraisals, right? And these kind of things. So it is fundamental to connect analytical decisions with operational processes. Otherwise, everything is useless. Everything is useless. So this is not about getting the best answers. This is about implementing answers that are directionally correct and can drive business impact. It doesn't have to be perfect, but it has to drive business impact. If it is not connected to operations, it's not going to. Not collocating data scientists with business teams. This is number 16 about the execution. So something that I have observed in many companies is that there is a tension between the business teams and the analytics teams. And this tension is normal. It's normal because they speak different languages. It's normal because they have different focuses. It's normal because they typically don't understand each other. So they have a resistance to talk to each other. Basically means that if they are not sitting together, they are never going to talk to each other. And what is really important is that it doesn't matter how your organization is, whether all your data scientists or data engineers are reporting to the same person. If somebody is working with marketing, just make him sit with marketing. If somebody is working with procurement, make him sit with procurement. They don't have to sit in the same, in your department's floor. So it is fundamental that people, data scientists are co-located with those teams that they are serving. Otherwise, probably things are not. Number 17, and we are getting close to the end. Number 17, managing projects in waterfall. Sometimes when I talk to technical people, I see a preference for waterfall. Because waterfall is easier for somebody technical, right? So somebody is going to tell you, these are my requirements, this is my deadline, and then you do it. And you start doing it, and you don't need to talk to anybody. You're just sitting in your lab, and you are just doing it. This is typically not how the real world works. Typically, how the real world works is your client has no idea of what you want, so he's not going to be able to give you any requirement until you produce something. The real world is that the hyperparameters of a model are impossible to identify a priori, right? I mean, um, insights and conclusions are typically not transferable from one market to another market, are typically not transferable from one project to another project in terms of what is going to be the best model. You have to try many options and find out what of the hundreds of models that you created is right. So waterfall is just not, it doesn't work. It doesn't work from a people's perspective, and it doesn't work from a technological perspective, analytics. It just doesn't work, right? So we have to go into agile. But agile is more complicated to run. It's far more complicated to run. And but my view is that agile works much better. It keeps clients much happier about the models that you are developing because you are giving them updates more often, and it helps to transform the culture of the organization much better. You are meeting your clients every 2 weeks rather than meeting them at the end. Is much, much better. So going into waterfall means that things are probably not going to go that well. Number 18, not being able to scale up pilots. Yeah, this is a very good one. I was in McKinsey. Who has been in consulting here? Okay, and when you have been in consulting, have you ever seen a pilot failing? I have never seen. Have you ever seen? I also have never seen a business case that works, but that's another story. Have you ever seen a pilot failing? Pilots don't fail, especially if you are doing them with a consultant. Pilots never fail because the consultant or whoever is doing that pilot is going to do whatever it takes to make the pilot successful. Pilots never fail. What is complicated is to scale up the pilots. And typically what happens is that you do the pilot goes very well, but at some point finance say, oh, we have to save money, or they say the priority is something else, and then the focus goes into something else. So that program that was intended to drive so much revenue, to reduce the cost so much, et cetera, never gets its full potential because you did a few pilots and you were not able to scale them up. And this is something that is something that happens again and again. And sometimes the success of the pilot, I mean, you make a pilot, is successful, and you start talking about how good you are, et cetera, but it means nothing for the organization. So that is something very important. Number 19, and there are only 25, so I'm reaching my end. Neglecting data governance and data security, right? Yeah, so data governance, people don't think about governance when you are building a model, et cetera, or when you are doing data engineering. People don't think about governance, right? Who cares about that, right? And data governance is fundamental because if you consider your data is an asset, there has to be a governance about managing this asset, right? And the governance can be very simple, but you need to have a policy, and the policy needs to specify who gets access to that, how you make sure data is clean, et cetera, and also security, right? Which is fundamental for this, and sometimes we are not paying enough attention to this, especially in those that are in highly regulated industries like banking or healthcare or even us. Data security is very, very important, right? Having anonymized information is very important, which, by the way, Cloudera allows to have anonymized information on access, which is a very nice feature. Yeah, but this is very, very important. And now I'm going to go to technology. Technology, we only have 4 ways of failing. As Kathy was saying, most of the ways you can fail are outside technology, right? But in technology, we can also screw up, right? So let's talk about the first one. Sometimes I see people saying, hey, do I have to prepare my data engineering platform before making models, or I start making models and then I think about my platform, or you see what I mean? So I start making models quick and dirty, and then I will see how I get my platform, because anyway I have to talk to finance, and they are likely not to give me capex, or I just invest in a very nice system where I'm going to put millions of dollars, and then I will think about the models. Both of them are wrong. You have to do it in parallel. So you have to refine, and we come again to agile and iterative working, right? So you have to define probably a number of pilots where you're going to choose some use cases, and you are deploying the infrastructure for that, and then you will grow it, and you will grow that, and you will grow that, and you will grow that. Uh, Obviously, if your data is trash, you're going to get trash as an output, but the way of doing it is doing it in parallel. So you don't wait for your infrastructure to be finished in order to start getting value from the data. But at the same time, you have to pay attention to clean your data. Number 21, not using the right tools. I have seen, for example, when we did our datathon, some of the participants in the datathon were using a lot of proprietary tools for analytics. And there are so many open source tools, and even, I mean, there are some, Cloudera is a distribution of one of these tools, but from my point of view, there is no reason to start to use proprietary tools for analytics. There are open source languages, Python, R. There are so many tools that are not proprietary that you can find a lot of information on the web. And now we are starting to have cloud as well. I think cloud is good, especially for some digital companies that are digitally native. I think that can work very well. But I see a lot of legacy, and I think it's not the right way. The right way is not to keep that legacy. Having data silos. I was talking before about having a more or less centralized organization initially, and I totally agree. That initial centralization has to expand to the whole organization, so you're going to let them go. That's totally fine, but you have to start with a scope that is clear. The same thing for data. I believe in only one data silo. Why do you need to have multiple data silos in the organization? Most big companies have multiple data silos. So you have department A with a data silo, department B with another data silo, but the value of data comes from connecting all these. And then you ask them for permission, they tell you, no, but this is so confidential that I can not give it to you. I believe in only one data silo. There has to be one data silo. This data silo has to include all internal and external information. What happens in some companies is that they buy a solution, like a GIS solution, they buy something that comes with data. And they don't integrate this external data into the data silo, into the data platform. But that external data has an amazing opportunity, right? Because internal data is something that data scientists and business people have been confronted with for decades. In telco, I mean, we have been using data for decades. In banking, probably for more time, right? Internal data is not going to change the business. It's just not going to change the business. The only data that can change the business is external data, because external data is data you have not seen before. And that's very important. So if you want to fundamentally change the operations of your business, if you want to fundamentally get into new areas, you need to get external data, and there are many sources. All those sources should go to the same data silo, because otherwise they will only be used by one department. There is social media, there is network benchmarking, there are maps, there is web scraping. There are so many ways of getting external data, sometimes paying, sometimes for free. I shouldn't say that. Not automating analytics with AI. A lot of people are afraid of, is AI going to take all the jobs? Yeah, I don't think that's going to happen, but what I do think is that the AI can be an extremely smart assistant for data scientists. I met the head of a very famous telecom company in Europe some time ago, and he told me that everything he did was automated. He didn't want to do anything manual because he knew that it would not be scalable. AI can be used for creating hundreds or thousands of variations of a model. AI can be used to automate feature prioritization. AI can be used to identify the obsolescence of models in an automatic way. So you can use a lot of automation in data science and analytics, and I think most companies are not doing enough in this. But I don't think AI is going to replace the job of data scientists or data engineers. I think that what is going to happen is the same thing we saw in software. Probably, I mean, you are maybe too young for that, but long time ago, people were programming in assembly, then C and C++ came, and all these languages. So we had higher and higher level languages in programming. The same thing is going to happen with analytics, right? So a lot of things are going to get automated, and I think it's a very good thing. So let's go to the end of this. We're going to go to finance. Finance is the most important part of any company, right? And there are two things here. Number one, I see companies not allocating budget, and I see companies allocating too much budget. It's just about, if you allocate too much budget, you're going to overspend, and things are not going to go that well. And if you don't allocate enough budget, certainly is you're not going to be able to deliver value from analytics, right? So this is something, and how much is the budget? It really depends. But this is something to take into account. And the second mistake that I see is, and I think I said something before, is not calculating the ROI of analytics investments. Most people that you ask, you tell them, what is the ROI of analytics? They have no clue. What is the impact that you got through analytics last year? They have no clue. And this is fundamental. If you don't know that, what are you doing, right? So finance should track all investments in analytics. And most situations, in most companies, analytics is not aligned in the ledger. So you cannot go to the ledger and say, hey, accounting, how much was analytics? Because there is not a line called analytics, right? In most companies, there is not a line for data. We are saying that data is an asset. Go to the ledger of your company and ask if there is a ledger line for data. You will have to put it under intangibles or under something that is not defined, right? So yes, I think measuring the ROI of analytics is very, very important. And this is the number 25, but there is a bonus. I'm going to give you 26. So this is the 26 top 25 analytics mistakes. The 26 is this. And I think I talked about that before. The political aspects of managing analytics are very important. Every organization is political. Polis means city in Greek, so every organization is like a city that you have to manage. Getting the support of the hierarchy, getting the support of the CEO is fundamental. An analytics transformation has to be driven top-down. It cannot happen bottom-up. It's not a revolution. It has to be driven top-down. That's why engaging with the C-suite, and in most cases, in most companies, heads of analytics are not in the C-suite. 20 years ago, chief marketing officers were not in the C-suite. They didn't have a seat in the C-suite. 10 years ago, chief digital officers were not sitting in the C-suite, right? And today, at least in Malaysia, chief data officers are not sitting in the C-suite. But it's very important to engage them. Otherwise, your transformation is not going to work because you are going to hit so many roadblocks. And this is something very, very important, right? The support has to come from the top. And you need to build a coalition of equals between the business leaders, IT, we didn't talk much about IT, IT and analytics. And this is a coalition of equals. Driving value from analytics require these three parts. And if they are not aligned under the direct leadership of a very data-driven CEO, is difficult to do that. When you look at companies that have been successful in analytics, there are three archetypes. And let me show you how the leadership of this C-level leadership is important. There are three archetypes. Also, according to McKinsey, I was in McKinsey, that's why I quote them. Number one, this is companies that are native digitally. So people understand data, people are technically savvy. So these companies in general are successful in analytics transformations. Second kind of company is, as I was saying before, those companies that have a very data-driven and very technology-oriented CEO. And that's why they are successful, because he's driving the agenda. And number three is companies that are in a situation of a crisis, maybe fighting for their existence. And those companies are also, in general, able to drive analytics transformation as an effort to change, basically because in that fight for existence, the CEO is involved. So keeping the board and C-levels aligned and getting help from them is very, very important. I think this is it. I hope I didn't bore you. And if you have any questions, let me know.
Thanks, Pedro. I believe you also have a blog on this, right?
Oh, yeah, I write things from time to time.
Well, it definitely resonated
Yeah.
a lot better. A lot definitely resonated. I think all, at least to ourselves,
Thank you.
we definitely experience a lot of these kind of a lot of these questions and a lot of these experiences as we are talking and dealing with many other organizations out there. Um, this is essentially what the meetups are all about. We essentially really want to, get someone like Pedro and someone that has an experience, an organization that have gone through it, to share experiences and share best practices out there, so that as a community, we all actually benefit very much from that. With that, I would like to very quickly move on to the Q&A. I would like to invite Doug and also Pedro up on stage again for Q&A. Questions? Sure.
Hello, my name is Eugene. I'm from SAS. So SAS is a company which does proprietary analytical tools. And Pedro, thanks a lot for the sharing of the 25 or 26 mistakes that you shouldn't make in analytics. But one point, no, because you did mention that you should. I'm not sure if you did mention avoiding proprietary tools, but I think maybe a combination of maybe a combination of both would probably help, since I know open source tools are where innovations where the innovation happens, but it is the proprietary tools that sometimes gives you the stability, the support, as well as the best practices that you need. Do you have any comments on that?
You can have both, right? I mean, Cloudera is an example, but there are other companies, right? That you can have an open source tool with a support, right? You know, I think some companies or some industries are more heavily in need of using proprietary tools. I'm thinking about airlines, for example. But what I see is that the speed you can get, the level of learning, finding code from the web, sharing with your colleagues is higher when you are working on open source. That was basically my point, right? I think, yeah, companies can be perfectly successful with proprietary tools, but I think you can go faster and you can go farther if you're using something more open source.
I'm not going to argue with that.
Hi, good evening. I am Soma from Cellcom Innovation Lab. Question is to that. So about this open source question, I've been using Cloudera for quite some time, and then this Cloudera data science workbench is really good. But I would like to know, is there any chance of open sourcing that? Because model management tools are really like proprietary tools. Most of them are proprietary tools. Thank you.
Yeah. It's not my decision, unfortunately. The line that we've tried to draw through the years at Cloudera is that the things that actually store and process your data are open source, and the things that are tools for IT to manage systems, to configure and deploy and so on, would be proprietary, so that we could have a sustainable business. And data science workbench is somewhere on the edge there. I see. We'll see also what happens after we complete our merger with Hortonworks, which should happen I think in January. We're expecting. There could be some surprises, but hopefully we'll close that. And I think Cloudera's open source strategy is likely to be revisited after that merger, because we will be the merged company will have all of Hortonworks customers who have different expectations about open source, and we don't want to alienate any of those customers. So it's possible it will change. We'll see.
Hi, I'm Feroz from Axiata. You know that everybody knows about MapR and the news when uh, Cloudera merged with Hortonworks, and then that's where MapR responded in the tweet that I saw that it says that this is what we are doing the last few years when both these companies about to merge. So we want to try to understand in what perspective that probably Cloudera with Hortonworks can beat MapR. Thank you.
I mean, both Cloudera and Hortonworks are much larger than MapR, and so combined will be that much larger yet. So they're not to our perception, a primary competitor. We don't see them a lot in competitive contexts. In terms of an open source strategy, they're far less open than Cloudera. I think Cloudera was arguably in the middle between Hortonworks having everything open source, MapR having very little open source, and Cloudera having this distinction between sort of runtime and operator tools. So I don't know if that's answering what you're after. I mean, I don't. Maybe I misunderstood the question.
Because I do has experiments with MapR, so I will understand that one of the advantages of MapR is that because it was they are rewriting back all the Hadoop using C instead of Java. So that's where it makes like the file sharing will be much faster. Is what I understand actually. So would that be an advantages of over Cloudera? I'm not so sure.
I mean, I'm sure they claim it's much faster. I don't know if that's been validated. We haven't seen a lot of, as I said, we haven't seen a lot of customers come to us and say we need to use MapR because it's much faster because they wrote it in C. That hasn't been. So I don't accept that as a fact. I would. It may be a claim they've made. I mean, after the merger, things are not going to change that dramatically. Cloudera and Hortonworks are already 75% or more the same software. We ship many of the same things. Some of that remaining 20 to 25% are things that are complementary. We've got different strengths, things that we've each went into, and so there's a few things that are redundant, which we'll need to simplify. But overall, I think we'll just have more engineers working on the same tools, making them better, optimizing them further. So I don't see I don't see it changing things remarkably in that respect.
Hi, I'm Buddhika from Axiata Analytics Center. This question is more towards the open source projects. So without a doubt, the Hadoop is the most I think, the best enabler and the biggest open source project for big data analytics. According to what you see, what is the next biggest challenging probably may replace Hadoop, the open source project so far you have seen?
I mean, we're already seeing, large portions of Hadoop getting replaced. MapReduce is still used for the biggest, longest running sort of batch jobs. It hasn't really been replaced there, but for most other sorts of work, Spark is a better tool. It's a simpler API. It's a higher level API. It's faster for any sort of iterative task. It supports more models. You can do streaming analytics in Spark. So there's a few cases where you can do things in MapReduce that wouldn't be possible in Spark, but fewer and fewer. And in terms of storage, HDFS is still a good tool. And on premises, it's probably the primary storage system that we're still seeing people use. In the cloud, people are moving towards the cloud native block storage engines, and we recommend and support that. It makes, if you're working in Amazon, it makes sense to keep everything in S3. So it's interesting as a company that's built around, Cloudera is not a company that is, we're not the Hadoop company. We're rather the open source big data company, and so we can. We're not tied to any particular technology. We don't want to force people to use anything but the best tool for the job. We want to enable them to use the best tool. So if S3 is a better tool than HFS, we want folks to use that, and in the cloud it usually is. We've also developed another storage engine that can replace HFS in many cases in Kudu. Very powerful tool to supports a lot of streaming applications, more sort of relational applications. It's a neat storage engine. I won't spend a lot of time talking about it, but just to the effect that already much of Hadoop has been replaced, and I expect that to continue. And each of these things will be replaced. It's why I think, as a business model, being a company that's dedicated to a specific technology is a mistake, because specific technologies will be replaced in this open source ecosystem and will become legacy over time. It may take a long time in some cases. Some things are going to have longer runs than others, but strategically, we need to be prepared for that.
Excuse me. This is about a question of business. So I would like to direct to Pedro, if I may. So from a startup perspective, everything runs from ground zero. And of course, I realized that after I attended this Cloudera session, I realized that analytics has many different levels, level 1, level 2, level 3. And from level 1, surely we will use much more structural way of getting data like time, hours, length, whatsoever. It's very structured. But as we go, I realized that it depends on technology that you adopted to help the company to move forward in various channels or capabilities. And then that's the difficult part, which I don't understand, that at what trigger point does it realize that we are in a level 2 and we need a different level of data analytics, level 2 of data analytics that requires like Cloudera or software and so whatsoever. Maybe you can point me a certain direction, that what's the trigger, what's the time.
What's the trigger? So I mean, level 1 is kind of BI, right? Level 2 was more statistical, statistically more advanced models that was referring as data science, and level 3 was machine learning, when you introduce a loop, a feedback loop with environment. What is the trigger? I mean, if I had to answer that question, I would say the trigger depends on the business. It depends on what business you are and what startup you are. And I'm going to give you an example. We did a datathon 1 month ago with a company that is called Go Car, and you might know them. It's a startup. You can rent cars. Very interesting company. You rent the car, you drive it, and you drop it in another place, and everything is in mobile phone. Very interesting. And obviously they have BI, because I mean, every company needs to have BI. A company without BI doesn't work, right? A company without analytics works, but a company without BI doesn't work. And then we were discussing about them, what kinds of needs you have in terms of data analytics, what will you need? And they were talking about, hey, you can use analytics for charging different prices to different kinds of customers, right? So if a customer is a more dangerous kind of customer, you will charge more for insurance. Otherwise, you will charge less. So that will be an application. Another application will be, how do I prioritize the locations, the pickup locations for my cars? I think it depends on the business needs. If you are able, from a business point of view, to think of problems that require complex predictions, or problems that requires complex use of data, then that's the moment in which you should start looking for these kind of solutions. As I said before, I think it's not technology driven, it's business driven. When the business says there are opportunities in using data, then let's use it. That's my view.
That makes a lot of sense to me. You're pragmatic.
Hi, this is Karim from CMB FinTech. Actually, Hadoop is meant for the write once and read many times, right? Actually, I have a doubt. Like, whenever I running the machine learning models, right? So I temporarily like create the output files in the Hadoop file system. Sometimes if it fails, then again I rerun the models. So I need to go and manually and delete the directory. So can it be possible, like we can change that slogan, like write once, read many times? Like, can they?
I mean, HFS is unlikely to change its semantics anytime soon, fundamentally. So HFS, I mean, you can delete things and create another file with the same name as the old one. You can move things atomically in HFS. You can rename a directory, but you know, it has a particular semantics. Kudu, for example, is very much a read-write engine with different semantics. HBase has read-write semantics as well. So there are other engines that permit the sort of thing you're talking about. It's hard to know without knowing more about your application whether those are the appropriate for your task.
Okay. And also actually I have one more, like I'm using Apache NiFi, around like OCR I'm doing. Do you have similar thing in Cloudera?
Do we have anything
similar? Yeah.
Well, NiFi is supported heavily by Hortonworks, and soon will be the same company. So yes, we'll be supporting NiFi shortly.
So similar thing.
I mean, this is you know, one of the rationales for the merger are that there are complementary things. I think both companies are. It's a big platform to support, and so we've been reluctant to take on new things because we already feel like we're supporting a lot of things. But now we can get a group that already knows how to operate that and use it well. So definitely be taking that. I think it's great technology.
Okay, thank you.
Any more questions? You can take one more.
We can take one. Anyone?
Sorry.
It's for Pedro.
Mm-hmm.
Okay, the sound from your 25 plus 1 lesson learned is summarized to politics, business, finance. So in Axiata case, how do you actually, from the finance side, how do you justify? Because I know analytics is quite difficult to see the ROI. How do we actually go in and justify to the CFO or to the board how much to spend, and how do we measure the benefits? I mean, tangibly.
Yeah. You have to make a business case. As I was saying before, during my 4 years in McKinsey and after and before, I have never seen a business case that works in my life. Have you ever seen? Have you ever seen a business case that basically says an ROI of 10 and then finally it's 10? Have you ever seen? I have never seen. You know, finance, obviously you need to create a business case, and that's the process in most companies, right? And in many companies, you are having the discussion about what is the ROI that data analytics is going to be. What is the ROI that digital is going to be? And it's very difficult to have an understanding, a view of that, right? I can understand that some companies are making the decision this way, are saying, hey, you know, we know the future is digital, we have to be digital, so we have to invest in all these things. I don't know exactly how much it's going to bring, but I think this is the right way to go. The same thing could be done with analytics, right? However, at the same time, you need to link that with, you need to be realistic about that. When you make the calculations, investing in a platform that is very expensive, very large, requires you to have a return on investment that requires, for example, to have a very large increase in revenues, that's probably not going to happen, right? So what I would say is the same thing that I have said before about having an iterative approach to the way we work in analytics, in which you start small and you are bringing it bigger, or you're making it bigger progressively. I think this is something that can be done from an investment perspective as well, right? So what I was saying before about ROI, I think you need to track your ROI. What is very difficult is to predict your ROI, right? And this is what the business case is all about. So I'm quite skeptical about predicting ROIs, but once you have invested, I think it is a must that you have to track that ROI and you have to know how much you are getting out of your data, your big data.